we're going to look at two scenarios here. The first scenario is we want to have, in retirement, we're going to retire at 65. And we're going to plan on sustaining ourselves through 88 years old. So 23 years. We want to draw $2,500 per month. But here's the catch. At 70 years of age, once our youngest grandchild is out of high school, we plan to move somewhere warmer. So we want to use $15,000 to move. If we assume that we are capable of drawing 5%, earning 5% interest, find the lump sum. Find that present value, that large amount that we need to start with to make this all happen. So this is really two separate problems that are added together. First, let's do the present value of the annuity, the 23 years at 5% and $2,500 a month. So we're going to find that present value by taking 2,500 times 3 open parentheses, 1 plus 5% is 0.05, divided by 12, is per month. 23 years is 276 months. Minus 1, close parentheses, divided by 0.05, divided by 12. Now we're drawing out, so we have that extra little term, so times 1 plus 0.05 divided by 12 to the power of 276. Close and close. So we'll punch that in. Do you get 409,563.49? So that is the amount that you would need at the beginning of this retirement at age 65 in order to fund that $2,500 a month that you want to live off of. Next, though, we need to account for that $15,000 lump sum to move. And what we need to do there is we need to find the present value of that $15,000. So the $15,000, but this is not going to be annuitized, it's just going to be compound interest because there's not going to be payments made. That's going to come out all at once. So 15,000 divided by 1 plus 0.05 divided by 12 because it is per month. And that is 5 years from 65 to 70. So how many months? 60 months. So 15,000 divided by 1 plus 0.05 divided by 12, power of 60. So that's 11,688.08. And now we just have to add those two future values together. So $421,251.57. Are there any questions on that, Press? Yeah, go ahead.
Where did you find the 60 months is from where?
60 months is from age 65 to 70 is 5 years. So times 12 makes the 60. Any other questions? Well, that one's quite a mouthful just on its own. But we're going to do another one similar to it. How many think you could do a problem like that right now if you had to? Okay. I guess I see I'm instilling confidence in the troops tonight. Well, we'll leave that up there. Well, we'll do another one, and we'll have to scroll back and forth, I guess. What we're going to do in this one is we figure we are now currently 25 years old. We want to have $500,000, $500,000 at age 65. We're going to invest it at, we're going to assume we can get 8% on our money. In 10 years, or at age 35, we want to draw out $25,000 to make a down payment on a house. What does that monthly payment have to be starting at 25 and going to 65 in order to not only get the 500,000 but to also cover that 25,000 drawn out? We're going to assume there are no penalties for drawing that money out. So once again, there are two problems here. The first problem is the 500,000. So let's figure out how much we need to pay every month at 8% to get to that 500,000. So it's 500,000 divided by 1, 2, 3. 1 plus 0.08 divided by 12. 25 to 65 is 40 years. So 40 times 12 is 480 months. Minus 1, close parentheses, divided by open parentheses, 0.08 divided by 12, close and close. So let's figure that out first. 500,000 divided by 1, 2, 3. 1 plus 0.08 divided by 12, close, power, 480, go out, minus 1, close, divided by open, 0.08 divided by 12, close and close. $143.23 a month. So that's how much we need in order to get, I screwed something up. You know what I did? I can't do that step first, sorry. Ignore what I just told you. I've got to take that 500,000 out of there because we're not shooting for 500,000. We have to shoot for 500,000 plus whatever that 25,000 takes. Told you these were tough problems, even I screwed it up. Sorry about that. Our first thing we have to do is we have to figure out what that 25,000 is taking out of this. And what we're really asking is if we had left that 25,000 in there, how much would it have amounted to? How much would it have built to at the end? So taking the 25,000 times Now again, this is just a single lump sum, so it's just a compound interest future value. 1 plus 0.08 is our interest rate, divided by 12, because it is still compounded monthly. How long is it going to sit there? Well, 10 years puts us at age 35. So 65 would be 30 years. 30 years is how long it would have sat there had we not taken it out. So that's 360 months. So we need to figure out what that would have been worth. 25,000 times 1 plus 0.08 divided by 12 to the power of 480. 606, 834, 64. So that's how much money that 25,000 you took out decreased your balance by. So we actually have to add that to the 500,000 that we need. So what we're really going to need to have is $1,106,834.64 is what we need to shoot for. So that's what we're going to have to figure our payment off of. So $1,106,834.64. Does everybody see where that $1,106,834 came from? We just took our 500,000 that we wanted to have, plus the amount that 25,000 took out of that final total by not being there for that 30 years. So now we're going to divide by 1, 2, 3. 1 plus 0.08. We're just back to this formula that we started the first time. Divided by 12, close, to the power of 480, minus 1, divided by, open 0.08, divided by 12, close, and close. That looks better, $317.05. There we go. What do you think? Any questions on that one? Are we ready to actually see what the extra credit question is? Who's a little nervous to see what the extra credit question is? Okay. So let's talk about Pat. Pat is currently 20 years old. At 30, wants to make a $20,000 down payment for a house. Wants to retire at 68 with $3,000 per month until he reaches 93 years of age. At 75, he's going to move, and it'll take $10,000 for him to make his move. Pat will earn 10% while paying in, and 6% while drawing out. So I'm going to actually give you a hand here and show you where the percents apply. So the 6% applies to this 10,000 he's going to draw out at 68. The 6% applies to the 3,000 per month from 68 to 93. The 10% applies to how much he's going to pay in each month, and that 20,000 he's going to draw out at 30. So the question is, how much does Pat need to put away each month from 20 until 68 to make this happen? We're going to leave this problem hanging out there. If you can give me the answer by noon tomorrow, I'll still accept it. It is worth 20 points extra credit. If you show all your work and you have like the lump sum at 65 or at 68, correct? I would give you partial credit for that. If you have at least that much. There's only like 405 points possible for the course, so 20 points extra credit could bring your grade up by as much as like 4.8%. Just so you're aware. So, I am going to take a look at another example, and I'm going to work it out completely so that you guys can refer back to this off that example. And yes, this is recording right now, and I will try to get that recording posted either tonight or very early in the morning so you can look at it. But I still suggest you take good notes so that you have it available for you to use. So we're going to talk about Chris. Right now, Chris is 22 years old. At 30, Chris wants to take out $12,000 for a house. While he's paying in, he figures he can earn 12%. Wants to retire at 67. Wants to draw out $3,200 per month until he reaches the age of 90. He's going to earn, during the time of drawing out, 5%. And at 75 is going to take out an additional 12,000. Well, let's change that number so it's not confusing to you. He's going to take out 9,000. Only 3 zeros and 9,000. Let's move. This is exactly the same problem as the other one, just different numbers. We start with the drawing out, the liquidation phase. Start with the payment. $3,200 a month times 1, 2, 3. 1 plus 5% while we're drawing, so 0.05 divided by 12. 67 to 90 is 23 years times 12 is 276 months, correct? 276 minus 1, close, divided by open, 0.05 divided by 12 times 1 plus 0.05 divided by 12 to the power of 276, close and close. I will pause for a second for you guys to get that written down. you get a lump sum of $524,241.27. Anybody else get that? Perfect. Next, we need to deal with the $9,000 to move. How many years after 67, after retirement, is that going to be used? Well, 67 to 75 is 8 years times 12 is 96 months. So it'd be 9,000 multiplied or divided. We need less than 9,000 because it's going to sit there for 8 years and grow. So divided by 1 plus 0.05 divided by 12 to the power of 96 months. So 9,000 divided by 1 plus 0.05 divided by 12 to the power 96. So this really only needs to be $6,037.90 to cover the $9,000 in moving costs. So now we have to add those numbers together. So $530,279.17 is what is required at 67 to cover the obligations after 67. But now we're going to need to add to that total to cover the one lump sum obligation before retirement, the $12,000. What that's going to take out of that lump sum, if it had been left from 30 to 67, which was 37 years, times 12 is what? 374.44? Is that correct? Months? 37 times 12? Yep. And that's going to be at the 12% while he's paying in. So $12,000 times 1 plus 0.12 divided by 12 to the power of 444 months. That's going to be missing out of that. Giving us $995,110.26. That's how much that is actually draining out of that retirement fund by removing that $12,000 lump sum. So we're going to add that to the 530. So what we really need is 1,525,389.43. And that is going to be divided by 1 plus 0.12 divided by 12 to the power of 22 to 67 is 45 years, which is what, 540 months? Minus 1, close, divided by 0.12 divided by 12, close and close. I'll give you a second to get that formula down. Giving us $71.10 a month. Sounds pretty doable. Now there's one thing we need to double check. we need to double check that at 8 years, which is where we draw out the 12,000, there's actually going to be 12,000 in there. So we're just going to take that $71.10 times 1 plus 0.12 divided by 12. The power of 96 is just 8 years minus 1 divided by 0.12 divided by 12, close to close. So 71.10 times 1 plus 0.12 divided by 12, close, power 96 minus 1, close, divided by open, 0.12 divided by 12, close, close. Guess what? They're not. Only going to have $11,370 at that point. So this can't happen. They won't have it. If they waited a year for the 12,000, they would have it. Now, in the problem I gave you, I made sure it works out, so you don't have to double check that. The problem here is mathematically, that amount, 7110, should cover both. It's just we don't have the 12,000 to take out after 8 years. Yours, I promise you, does work out. Anyway, up until that point, the math for your problem is all the same. You don't have to do this double check. I just do it because I'm uptight. Any questions? Okay, I'm going to cut off the recording there, and I'm going to start processing the recordings for you.